We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 8, Exercise 8.8. Next question is, an aeroplane takes 1 hour less for a journey of 1200 km if its speed is increased by 100 km an hour from its usual speed of the plane. Find its usual speed. So let us assume that the usual speed of the plane is x. Now it will increase to x plus 100 and the time will be less. So what is the time? Let us take this condition. Time is distance by speed. Distance will remain same in both the cases. This t2 will also be 1200, but here we assume the speed is x, so time will be 1200 by x. Here we took 100 also in addition, so this will be x plus 100, and the time difference, that is 1 hour less, that is the difference of the time, will be 1 hour. It will be 1200 by x minus 1200 by x plus 10 x plus 100 equal to 1 hour. This is going to be our equation. So what do? Take 1200 outside. This I'm taking outside. X plus 100 will come here. Minus x will go here. Then we have x plus 100. This is going to be 1. So x gets cancelled. This will be 1 2 0 0 0 0. 1 2 0 0 0 0. And I'm taking this on the numerator, that is x square plus 100x. X square plus 100x. And bring this here. It will be minus 1 2 0 0 0 0 equal to 0. So this is our equation. Now this 4 zeros can be written as, or you can say 1,20,000 can be written as 300 into 400. Always 4th is a 12 and 4 zeros. So now this 100 we can write as 400 minus 300. So we can write it as x square plus 400x minus 300x minus 120,000 equal to 0. Now I am taking x common, x plus 400 minus 300 common, x plus 400 equal to 0. So do we get x minus 300 and x plus 400 as the factors? This will give us x equal to 300. This will give us x equal to minus 400. Speed cannot be negative, so we discard this. X equal to 300. That is the usual speed of plane is 300 km an hour. A train covers a distance of 90 km at a uniform speed. Had the speed been 15 km an hour more, it would have taken 30 minutes less from the journey. Find the original speed of the train. So let us assume the original speed is x. Now the speed is increased by 15, so the next increased speed will be this. So what is the time taken in the first situation? Distance remains the same, 90 km by x. Time is distance by speed. Distance, this is speed, this is. Time 2 will be, distance remains the same, speed will be x plus 15. Now what is the difference of the time? That is t1 minus t2, it will be 30 minutes. So 90 by x minus 90 by x plus 15, this is t1 minus t2. This will be 30 minutes. So 30 minutes divided by 60, so it will be an hour. So 1 by 2. 1 by 2 is the time. I'm taking 90 outside. This will be x plus 15 here minus x by x into x plus 15 equal to half. This gets cancelled. So I'm taking this on right hand side and 2 with 90. So 90 into 15 into 2, and here we have x square plus 15x. This is x square plus 15x. So do we get x square plus 15x? And this is 15 into 2 is 30, 30 into 90 is 2700. So the equation becomes x square plus 15x minus 2700 equal to 0. 2700 can be written as 45 into 60. This is 2700 only. So what do we get from here? X square plus 60x minus 45x minus 2700 equal to 0. So x you take common, x plus 60, take minus 45 common, x plus 60 equal to 0. The two factors are x plus 60 and x minus 45 equal to 0. From here you get x equal to minus 60, and from here you get x equal to 45. This we can discard because the speed cannot be negative. x equal to 45. This is the original speed of the train. A train travels 360 km at a uniform speed. That is uniform speed, the distance is this much. So this is distance. If the speed had been 5 km/h more, it would have taken 1 hour less for the same journey. Find the speed of the train. Let us assume x is the speed of the usual speed of the train. If we increase by 5, it will be x plus 5. So what is the time taken at first go? This time is distance by speed. Distance is 360. Speed we are assumed to be x. The time 2 will be 360. Distance remains the same. Now this will be x plus 5. That is increased speed. So time difference is 1 hour. So t1 minus t2 is 1 hour. That is 360 by x minus 360 by x plus 5 equal to 1 hour. So this is what you get. The 360 you can take common. X plus 5 minus x by x into x plus 5. This gets cancelled. 5 into 360, that is 1800, and x square plus 5x goes here. Now bring this here. So x square plus 5x minus 1800 equal to 0. This is our equation. 1800 can be written as 40 into 45. So for 5x, we can write it as x square minus 40x plus 40 means 40x, 45x minus 40x is 5x. So x square minus 40x plus 45x minus 1800. Take x common, x minus 40. Take 45 common, x minus 40. X minus 40 can be taken out, so x plus 45 will remain. Here you get x equal to minus 45. Here you get x equal to 40. So this is negative, so you don't take it. Negative cannot be the speed. X equal to 40 is our original speed of the train. An express train take 1 hour less, so this is the time difference. Then a passenger train to travel 132 km between Mysore and Bangalore. If the average speed of the express train is 11 km more than that of the passenger train, if we take passenger train speed as x, then the express train speed will be x plus 11, right? Express train is always faster than passenger train. Now what is the distance? 132. So t1 will be 132 by x. t2 will be, for the express train, distance remains the same. It will be x plus 11. And what is the difference of time between these two train? 1 hour. So 132 by x minus 132 by x plus 11 will be equal to 1. So this is how we solve it. So 132 we can take common. X plus 11 goes here. This x goes here. And this will be x square plus 11x. X square plus 11x equal to 1. This gets cancelled. 132 into 11 is 1452. I'm taking this on this side, x square plus 11x. So the equation becomes, I'm taking this on this side. So x square plus 11x minus 1452 equal to 0. This is our equation. Now 1452 can be written as 44 into 33. This multiplication is 1452 only. Why we did that? Because 44 minus 33 is 11. So I can write it as x square plus 44x minus 33x minus 1452 equal to 0. So I can take x common, x plus 44. I can take minus 33 common. It will be x plus 44 to 0. Now I can take x plus 44 common. X minus 33 equal to 0. This gives me minus 44. This gives me 33. I can take this because this is negative. So 33 is the speed of the passenger train. So what will be the speed of express train? 33 plus 11 is 44. So we have the passenger train speed is 33 and speed of express train is 44. The aeroplane left 50 minutes later than its scheduled time, and in order to reach the destination 1250 km away in time, it had to increase its speed by 250 km an hour for its usual speed. Find the usual speed. So let us assume the usual speed is x. Now the increased speed is x plus 250. So what is the time for x speed? The distance remains the same. What is the time 2? Distance remains the same. The speed will be x plus 250. Now the difference of time is 50 minutes. 50 minutes, that is 50 by 60 hour. It will be 5 by 6. Let us take the difference of this. 1250 by x minus 1250 by x plus 250 equal to 5 by 6. This is our equation. You can take 1250 common. This is x plus 250 minus x 1250, sorry, x plus, no, 250 only, because 1250 I have taken already outside. Then we have this x square plus 250x, x square plus 250x equal to 5 by 6. This get cancelled. Now I am taking this on the right hand side and 5 by 6 on the left hand side. This will be 1250 into 250. When this comes on this side, it will be reciprocal, so 6 by 5. This goes here, x square plus 250x. Now the equation becomes x square plus 250x minus, I'm taking this on this side, and this will come as 375000. If you multiply this, 5 5 is 25, 5 6 is 30, 300. So you multiply 125 by 3, this is 375, and you have 1 2 3 zeros. This will come as 375000. Now 375000 can be written as 500 into 750, right? And this will give us 250 also. So this 250x can be written as minus 500x plus 750. You can take x common from here, x minus 500. You can take 750 common from here, x minus 500. This will give you x minus 500 and x plus 750. This we discard because it will give us minus 70, which is the negative speed, which is not possible. X equal to 500, this is our speed. So this is the usual speed of the plane. While boarding an aeroplane, a passenger got hurt. The pilot, showing promptness and concern, made arrangements to hospitalize the injured, so that the plane started late by 30 minutes to reach the destination, 1500 km away in time. The pilot increased the speed by 100 km an hour. Find the original speed per hour of the plane. So the same situation is there, but the only question is, the language has been changed. The things remain the same. That is, if x is the speed, usual speed, original speed, x plus, what is the speed increase? 100. X plus 100 is the increment in the speed. Time one will be, distance remains the same for both the cases. Here we take the speed as x, here we take the speed as increased speed. And what is the difference of time? It is 30 minutes. Right? 30 minutes. 30 by 60 is hour, it is half. So difference of this time is half, 30 minutes. So 1500 by x minus 1500 by x plus 100. This gives you half. I'm taking 1500 outside. This goes x plus 100 up. This goes here minus x. And this will be x square plus 100x. X square plus 100x equal to half. This gets cancelled. So I'm taking 2 here, 2 on this side, and x square plus 100 here. 1500 into 100 into 2 equal to x square plus 100x. So our equation becomes 100 plus x square plus 100x minus 15 into 2 is 30, and then we have 4 zeros also. So we have 3 with 5 zeros. So this will come as, you can write this 3 lakh as 600 into 500. 600 into 500 will give us 4 zeros, 1, 2, 3, 4, and 5, 6 are 30. So this is 3 lakh. So now you can take x common from here, x plus 600. You can take minus 500 common from here, x plus 600. So x minus 500 and x plus 600 are the factors. This gives us x equal to 500, and this gives us x equal to minus 600. So we discard this because speed cannot be negative. X is 500. This is the original speed of the plane, 500 km an hour. A motorboat whose speed in still water is 80 km an hour takes 1 hour more to go 24 km upstream than to return down to the same point. So now the distance is again same for both the cases, upstream and downstream. And the motorboat whose speed is still water is 18. So when it goes upstream, that is, if we assume the speed of the stream as x, so when it goes upstream, that is, it will be 18 minus x, because upstream the stream is on the opposite side, so it is against the movement of the boat. So this will be the speed, and when it is coming downstream, it will be 18 plus x, because this x is going to facilitate the downward direction. So now let us take the time difference as 1 hour. So t1 will be t upstream. T upstream will be, the distance remains the same, 24 by 18 minus x, and t downstream is 24 by 18 plus x. Because time is distance by speed. Distance remains the same. Speed upstream is 18 minus x, downstream is 18 plus x. So the difference is, that is 24 by 18 minus x minus 24 by 18 plus x. The difference is 1 hour. So this is going to be your equation. This is what you get. So you can take 24 common. 18 plus x goes here. And minus 18 minus x. So minus 18 plus x it would be. So this is 18 plus x, 18 minus x, a plus b, a minus b. So I'll just square them. A square minus b square. Take this here. And this is 18, 18 get cancels. You have x plus x as 2x. 24 into 2x is equal to 18 square is 324 minus x square. So this will be 48x. Now bring these two here. So x square minus 324 plus 48x equal to 0. So what do we get? This 324 and 48. So we have to write 324 as 54 into 6. This gives you 324. So x square, you can write this 48x as 54x minus 6x, because 54 into 6 is 324. So this gives, take x common, so x plus 54, you take minus 6 common, x plus 54. X plus 54 you can take common, x minus 6 will be the factor x plus 54 and x minus 6. This gives you x equal to 6, this gives you x equal to minus 54. This will discard, x equal to c. This is the speed of the stream, which is 6 km an hour. So this is about this exercise. Thank you so much. Take care of yourself.